Hello, students. Today we're going to work on Notes 13, and this is a set of notes. It's a little unusual because it's mostly just looking at some examples that are tying together how we would use tables and functions and graphs. So because of that, I've tried to put both the front and the back together on this screen, and I know that makes it a little small, but hopefully you'll be able to enlarge it to be able to see and fill in your notes. So our example is really all one comparison of two stores that are selling t-shirts. And so the soccer team is wanting to order shirts. They're going to look at a store called Quality Clothes and then another store called T-Rific. And so the first one is about Quality Clothes, and they charge a $30 design fee plus, and then $6 per shirt that's printed. So we can complete a table and find out more about what our costs would be. So if 10 shirts were ordered, then we would still have to pay the $30 fee plus, and then $6 for every shirt that's ordered. So $6 in this case times 10. And so we would have, of course, you could use a calculator, but we'd take 6 times 10, which is 60, and add 30, and we would come up with our cost of $90 for 10 t-shirts. And if we switch that to 20 t-shirts, then that simply changes where I had the 10. Everything else would stay the same. So we would switch the 10 to a 20, and then we'd do 6 times 20, which is 120. Adding 30 would give us a total cost of $120. Or excuse me, $150. $150. And now our next question is a little bit different, or our next line in the table, because here I've shown you the process of taking 30 plus 6 times 40. So hopefully you can see that that 40 is in the place of where we've been writing our number of shirts ordered. So 40 would be our number of shirts ordered. If we took 6 times 40, that's 240, plus 30, that would give us $270 as our total cost. And then finally, I have 180 as my total cost, and we'd want to figure out our amount of t-shirts ordered. Now, I'm hoping that maybe you can think this through backwards. We've been adding on a fee of 30. So if we took that fee of 30 off, that would be 150. And then there'd be $6 per shirt. So we could take 6 and divide by, take 150 and divide by 6. And if we did that, we would actually find out that there would be 25 shirts ordered. And so we could say that our process for that one would be to take 30 plus 6 times, and then again, we found out that there were 25 shirts ordered. Now, this can all be set up so that we could do some algebra to make these calculations. Instead of just having an open parentheses, I could be writing this process as 30 plus 6 times, and then what's changing each time is your number of shirts. So I could call that X, and that would equal then my, I'm going to switch colors. That would equal my cost. And so you're seeing that the cost is changing based on the number of t-shirts. So that gets us to some vocabulary that we are wanting to fill in. So in number 2 there, the blanks for independent variable. The independent variable is that amount that keeps changing that then affects our final answer. So the independent variable is, for this problem, the number of shirts. So the number of shirts. And the amount that we're calculating that depends on our number of shirts is the cost of the shirts. So that would be our dependent variable. That will be affected by how many shirts we're ordering. And so we would say that the cost of the shirts, is a function of, or you might also say depends on, and then it depends on the number of shirts. So the number that's ordered. So in part 3, we're going to take this information and introduce notation called function notation. This is asking you to write a function rule right here. Write a function rule for quality clothes. Now, for this function rule, they would like for you to use Q as the cost in dollars and N as the number of t-shirts ordered. So a function rule looks like this. You'll have Q, whatever they tell you to use for your rule, of N. That's how you say it, Q of N. It looks like multiplication, but it is not. It's stated as Q of N equals, and then you state your rule, which is the process that we've been using. So we've been taking 30 and adding to that 6 times our number of shirts. Now, I like to keep the variable first, so I'm actually going to do 6 times our number of shirts and then plus 30. So that's our function rule for calculating what we calculated in our table up above. So every time that your number of shirts changes, we would change the N in our function rule. And we can use this information to make a table and graph our data. So one nice thing about a function rule is that you can set it up just like you would, like we did in the lesson 12, in a table where your N is your number of shirts in this case, and then Q of N is the cost. So it's always nice to look at 0, and we didn't look at that in our table up above. So what if we didn't order any shirts at all? Would it still cost us? Well, we could look at Q of 0, which means that we would do 6 times 0 plus 30. And 6 times 0 plus 30 gives us an answer of 30, because 6 times 0 is 0, and then plus 30. So Q of 0, and I'm trying to use that notation so you can see it being used, is equal to 30. So when there are 0 shirts, it's going to cost $30 because of that original setup fee. Now the other values I'm just going to use from the table up above. So when there were 10 shirts, we found that our cost was $90. When there were 20 shirts, we found out that our cost was $150. When we had 40 shirts, our cost was $270. And our last row, when we had 25 shirts, we saw that we had $180. And then we can take that information and make a graph. And when you do your graph, you need to label what each of the different variables represent. So our N represented the number of shirts, and our Q of N represented our cost. So give me just a second. I'm trying to write that sideways. And I have my window open. My dog is barking. So this would be the cost of the shirts. All right. So the other thing that we'll have to take into consideration as we do this graph is the scale that we're going to use. We can see that our number of shirts is staying in numbers that we couldn't count by ones. We don't have enough squares to go up to 40 by ones, but we could use a fairly low scale. So if we count by fives on the x-axis, that's our number of shirts axis, we could get up to 40. Now, always the corner is 0, 0. Whenever you're dealing with money and numbers of items, you're using just the first quadrant. So we just have this top right corner of the graph. So we could go 0 and then 5 and 10. I'm not going to write the next line, or I'm not going to write all the lines. I'll let you see that that's going to be 10, but it's just going to get really messy. So I'm going to skip 10 for writing it down. I'm going to count it. And then my next line, I'm going to go 15 and then 20. And then my next one I'm going to write is 25. And I'm going to keep going. So 30 and then 35 and then 40 and then 45. And I'm going to stop there, but we could keep going. But if I go by fives on the y-axis, on the up and down, I won't be able to get to my highest number of 270. So I'm going to have to use a different scale. And since my beginning number was a 30, that's actually a good number to use for the scale. So my first mark's going to be 30. I'm not going to write it, but my next one is 60. My next one after that is 90. Then 120. The next one I'm going to write is 150. And we have 180. The next one will be 210. Then 240. Then 270. And we could keep going, but 270 is the top number in my table. So I'll stop there. And now you will plot your points. So when your number of shirts was 0, the cost was $30. When the number of shirts was 10s, you want to make sure you're on the 10 row for your X's or for your N's. Then our cost was 90. When the number of shirts was 20, I skipped 20. Then our cost was $150. When it was 40, so make sure you're on 40, then our cost was $270. And when we had 25, our cost was $180. And what you should be noticing is that all of your points will line up in a line. And so we're going to go ahead and connect those to show that this relationship is steadily increasing in a linear form. And that would be a picture of the information. So you've got a table, you've got a function, Q of n equals 6n plus 30, and you have a graph all representing what's going on for this first store called Quality Clothes. And then question number 5 actually starts us in on the next store called Terrific. So Terrific has a different amount that they charge. They charge a $20 design fee and then $8 per shirt printed. And so if we set up our table, now I left these blank, but this would be the number of shirts. And we have your process. And then we're calculating the cost in dollars. I'm just going to use the money symbol there. And I went ahead and kept the same numbers as we used in our previous investigation. So we had, for this one, a $20 design fee plus $8. And then what's changing every time is our number of shirts. So for the first one, it's 10. So we could take 8 times 10, which is 80, add 20, and we'll get a cost of $100. And then we could go on and continue to do this. Sorry about that. For our 20 number of shirts, that would be 20 plus 8 times 20. Go shut my door. And then we could do 8 times 20 is 160 plus 20. That gives you a total cost of 180. And we'll continue on with filling in this table. So 20 plus 8 times, and then our number of shirts changes to 40. And so your total cost there would be 340. Again, you could use a calculator for this as needed. And then finally, when there are 25 shirts, so 20 plus 8 times 25, and your total cost for that is 220. So once again, we see that the cost of the shirts is a function of the number ordered, the number of shirts. So for your notes, you'll need to turn to the back, and I've got it showing on the video so that you can see both the front and the back at the same time, because we're going to be doing some comparisons. So question number 7, which is on the back of your papers, says that they would like for us to use R as the cost in dollars, and again N as your number of shirts, and they'd like for us to write a function rule for this store called T-rific. So just as we did with the Q of N, we'll use the letter R. So R of N. R of N equals, and this time we want to make up our rule like we did for the quality close. So again, I like to put my variable first. And so what was changing each time was associated with that $8. So it was $8 for every shirt. So my N, my number of shirts, and then adding to that $20, that design fee. And so R of N equals 8N plus 20. And then we can use that information to set up our table so that we could make a graph. So we've got N and we have R of N. So we're going to look at your second page where it asks for a table, and we've already defined the function R of N equals 8N plus 20. So in our table, it would be nice to, again, look at what happens with a 0. So we'll plug in 0 for the N, and that would be read as R of 0. So R of 0 would equal, and then for our new rule, we have 8 times, and we would plug in the 0 for the N, and then add 20. So 8 times 0 plus 20 is what this rule would ask us to do, and that equals a cost of 20. So R of 0 equals 20. And then these other values we'll pick up from the table that we completed on the other page. So when we order 10 shirts, that is going to give us $100 for the cost. When we order 20 shirts from your table on the front side, that's going to give us $180 in cost. 40 shirts is going to cost $340. And finally, 25 shirts is going to cost $220. And then we will set up the graph. So on the graph, we need to identify what your x-axis is. And so just like our previous graph, that would be the number of shirts. And your y-axis is going to be the cost of the shirts. And we'll have to set up our scale. So our scale for the x's can be similar, or can be the same actually, as what we used on your previous graph. So remember, the corner is 0, and we can go by 5s. And again, I'm not going to try to label every line, but every line counts. So 5, and then your next line would be 10, and then I'll label 15, and then 20, 25, 30, 35, 40, 45, and that should be enough. Now, our y-axis, our numbers are a little bit bigger, and so I'm going to make sure that I can get to that largest number of 340. So I'm actually going to go by 40s. So I'll make my, of course, the corner is 0. I'll make my first line up from that be 40. And I'm going to count by 40s. So I'm not going to label everyone, but everyone counts. So 40, then 80, then 120, then 160. I'll label 200. Then 240, I'll label 280. Then 320, I'll label 360. And that will be enough to get to my highest value. So now we'll plot our points. Now, your first point is 0, 20. So 0, 20 is going to be on the axis halfway between the 0 and the 40. So 0, 20 is your first one. Your next one is 10 and 100. And so my line that's not labeled is 80. My next one is 120. So 100 is going to be between 80 and 120. Then for 20, I have 180. So that same thing's going to happen. I've got a line for 160 and a line for 200. So the 180 is going to be right in the middle of those. At 40, I have 340. So that's going to be on the line in between 320 and 360. So we'll have that. And my last point is at 25 and 220. And so at 25, I have my 200 marked, and I'll go right in between 200 and 240. Again, this is linear, so we will connect those points in a line to show the relationship. So there you have the two graphs. They look very similar, and you do have to pay attention to the scale for the x's and the y's. So now we're going to practice using the function notation. So number 9 says, using the two rules, how much money would it cost to order 30 t-shirts from each company? So if you look back to the front side of your paper, Q of N, we set up to be 6N plus 30. So let's do that one first. That means Q of 30. Now that's a number that we have not calculated yet, but again, you say it as Q of 30, and the 30 is the number that we are going to substitute in for the n. So this number will go in a parentheses replacing the n. And then you just will continue to do your calculations. So Q of 30 would be 6 times 30, which is 180, plus 30. And that's going to give you, so this is 180 plus 30. We could do that on your calculator. So 180 plus 30 is going to give you 210. And so the cost of the clothes at Quality Clothes is going to be $210. Now, when we compare that to the Terrific company, their rule for R of N was 8N plus 20. So when we use the R of 30, we'll do 8 times, and then we'll plug in our value of N, which for this problem, again, is 30. And so R of 30, remember you could use your calculators if you want to. R of 30 is going to equal, well, 8 times 30 is 240. So this is 240 plus 20. And again, you could use your calculator to do that. So 240 plus 20 makes 260. And so the cost is $260. And then in question 10, another chance to use the two rules. So in question 10, it says, how much money would it cost to order 5 t-shirts from each company? So notice that it's the same rule for Q of 5. I'm going to write the Q rule up above it, that Q of N, just like we had in the first problem, Q of N is equal to 6N plus 30. So Q of 5 would be 6 times, and then we'll put in the 5. So 6 times 5 plus 30. So Q of 5 is going to be the answer to 6 times 5, which is 30, plus 30, and we're going to get 60. So $60. And then comparing that to R of 5. So R of N, remember our rule, is 8N plus 20. So we'll do R of 5. That's going to be 8 times. And then in place of the N, we're going to use a 5. And so R of 5 is going to equal, and this becomes 40 plus 20, which is 60. So $60. So some things that we could notice that are going on with the two companies: when you have your smaller orders, they seem to be the same price. So when only 5 shirts are ordered, the two companies cost the same. But as your number of shirt orders goes higher, so when we get to 30, you can see that your cost at Terrific was actually higher than your cost at Quality. And so that's what functions do. They help us to use rules to describe situations, and then by describing them, we can also use those rules to compare what's happening. So number 11 asks you, where does the graph of quality clothes cross the y-axis? So that's on the front page, and you'll see that we use that as our starting value. So that was when we had the ordered pairs 0 and a cost. And the cost on the front page, when your X was a 0, or when, your number of shirts was a 0, was 30. So we had 0, 30. And that means that the cost is $30 when no shirts are purchased. So sometimes that's called an initial cost. And then for Terrific, when your number of shirts was 0, we plugged that in. That's at the top of this page. Your initial cost, or your beginning cost, was 20. And so we need to make a sentence for that. The cost, so let me get this erased and try again. The cost is $20 when no shirts are purchased. So it looks like one of them might be lower to start with, but it doesn't take very long for the quality clothes cost to become less than the terrific cost. So good luck with your homework today. You'll be having to fill in several tables and graphs and answer questions about what's going on with the situations that those tables, graphs, and functions are describing.